Welcome to Amplified Education, your exam prep friend. Today we are looking at grade 10 electric circuits. Please pause the video and try the question on your own. The question reads, consider the circuit given below. The direction of the conventional current is shown using an arrow next to the battery. The current in A2 is half the current in A1. The resistance of the bulb is 5 ohms. Switch S is closed. The first question says define the term current. 1.1. Current is the rate of flow of charge. 1.2. Explain what is meant by power. So power is the rate at which work is done or energy is transferred. Is transferred. 1.3. So 1.3 says we must calculate the value of R. So here is R there. And we know that in R, there is 2 amps of current that is passing through R. But we are told here that the current in A2, where's A2 here, is half the current in A1. So that would be 1 amp that is passing through the 10 ohm. So if we can just find the voltage across the parallel branch, we could use that voltage to find the value of R. And so V parallel is equal to IR, but we are going to use particularly the 10 ohms to find the voltage in parallel. And so that would be 1 multiplied by 10, and that gives us 10 volts. Now, once we have the voltage, we can say the value of R is equal to V parallel divided by the current, which is equal to 10 over 2 amps, and that would give us 5 ohms. 1.3 says we must define the term voltage. I'm going to try and define it here. That's 1.4. I'm going to try and define it there. Voltage is the work done per unit positive charge. Or the work done per coulomb of charge. All right. And then if we go to 1.5, it says calculate the reading on VT. Now we know that the value on VT would be equal to the voltage over the parallel branch, okay, V parallel, plus the voltage on V1. So if we can find the voltage on V1, because we have already found the voltage for the parallel section and we just add them, that would be VT. So in other words, VT is equal to V parallel plus V bulb, which is V1. And the value of V1 is equal to IR, which is, now we need to obviously find the total current that is flowing through the bulb because the bulb is connected in series. Now we know that 1 amp is coming from there and 2 amps is coming from there. So 2 plus 1 gives us 3 amps of current that is flowing through the bulb. So that is 3 multiplied by 5, and that gives us 15 volts. And so if we take the 10 volts over the parallel section of the circuit and add that to 15, we then get 25 volts. Then that would be the total voltage that is supplied by the battery. and 1.6, just go down a bit. All right, I'm going to try and do 1.6 here so that we keep everything in one place. 1.6 says determine the polarity of X. X is X should be positive because X is showing that, look at the arrow for the current here, the conventional current. It always flows from the positive terminal to the negative terminal. That's the flow of positive charges. And so X has to be a positive terminal. Then 1.7 says calculate the charge that flows through ammeter A3 in 10 hours. So for that, we use the formula Q equals IT. We already know the current flowing through A3 is 3 amps, right? Because A3 is not connected in the parallel section of the circuit. So that is 3 amps for 10 hours. And we have to convert that to seconds. So we'll just multiply by 3,600 or by 60 times 60. All right, and that would get us our answer. Let me just multiply that quickly. 3 times 10 times 3,600 gives us 108,000 coulombs. And then 1.8 says what energy conversion occurs in the light bulb as it operates. We are converting electrical energy in the light bulb into heat and light energy. And 1.9 then says calculate the energy dissipated in the light bulb in 20 hours. So the electrical energy, don't forget, is the input energy, right? So that's the input energy. And so if we assume that what is input energy is actually what comes out, then we could use the formula W equals, is it VQ? Yeah, it is VQ. VQ, which is can be further broken down into V multiplied by IT. So basically the charge is equal to the IT part. And then after doing that, we know the voltage over the bulb. The voltage over the bulb is 15 volts. We know the current flowing through the bulb is 3 amps. And now this bulb is operating for 20 hours times obviously 3,600 to get that into seconds. And energy is obviously calculated in joules. And so if you multiply that out, you will get 216,000 joules of energy, well, of electrical energy is transferred into the bulb, right? And if we assume all of that is converted to heat and light, then 216,000 joules of energy is given off as heat and light. Then let me see, I think we do have another question there. Yes, we do. That is 1.10. 1.10 says switch S is now open. How will this affect the brightness of the bulb? So obviously, if you open switch S, now switch S is here. If you open it, you're pretty much getting rid of this resistor, which means now you have a series circuit, right? And a series circuit always has a higher equivalence resistance, which means your total resistance would have increased by you just doing that. And your current would actually decrease. Now, according to the formula that we've just used now, which is W equals VIT, right? VIT. The current is directly proportional to the energy to the electrical energy that is transferred into the bulb or that is dissipated from the bulb. So if the current actually decreases, then the brightness, right? Remember, current is related to brightness. So if current decreases, then brightness as well, brightness should actually decrease. So that's pretty much how you would look at that. And so um, current is directly proportional to, so W is directly proportional to I. And so current, when current decreases, then the energy dissipated should also decrease. I hope that makes sense. There is another formula that is obviously used to explain the energy that is dissipated in the bulb, and that is P equals I squared R. This formula, we will use it in grade 11, but I think it's also very important because power, remember, is the rate at which energy is transferred. So if power is directly proportional to current, assuming that the resistance of the bulb is constant, then if the current, the total current decreases, then the total power dissipated or energy dissipated um, over the bulb should also decrease. Okay, that's pretty much what that's about. I hope that helps. Thank you.